Well, hello and welcome K to 6 to our celebration here at Snowy Hydro for National Science Week. We are so excited and delighted to be able to bring to you a virtual panel Q&A. So Q&A, that's questions and answers. And thanks to all of you out there, we have received some absolutely fantastic questions, some that have got us really thinking. So we thank you very much for supplying and submitting some very curly questions for us to get through today. So we're going to take the format that will put your questions around some themes, because we received so many that we've kind of themed it up, and our experts here on the panel will go through and answer and discuss each of those areas that you out there, K to 6, are interested in. So thank you. First of all, I'd like to say it's my absolute privilege to give the acknowledgement of country. We would like to acknowledge the traditional custodians of the land, the Nagario people on which we meet today, and pay our respects to elders past and present. We're all on different lands today, and so we acknowledge those who have come before us. Well, hi, I'm Carolyn Hewitt, and I am the Education Programs Manager for Snowy Hydro and your facilitator for today. My role here at Snowy Hydro is to work in the education programs team, and we develop a lot of programs to really meet the needs of teachers, students, and now that, of course, we're all working at home, for you home learners. But you know, the best part about my role is that I get to work across the whole business. So I get to meet some very interesting and exciting people here at Snowy Hydro. And today you are also going to meet those people. Well, only some of them. So here's what we're going to do. We've got our fabulous group of panelists waiting to answer all your questions and have a discussion. So I'd like to start by introducing our panelists. So I'll introduce each one and give you their position here at Snowy Hydro. And then panelists, I'm going to ask you to talk a little bit about yourselves. So is everyone right with that? We're all good? Great, let's go. All right, so I'm going to start off with Guy Boardman, and he's our Manager of Major Accident Prevention. Over to you, Guy.
Good morning, everybody. I hope you're having a wonderful day, and thanks for coming today. So what am I talking about, Carolyn, here now? I'm just going to introduce myself and say what I do.
Yep, just talk about yourself. Very good. Thank you, Guy.
So, as Carolyn said, my name is Guy Boardman, and my job at Snowy Hydro is the Manager of Major Accident Prevention. So really what my job entails is, across our scheme, we have got some amazing bits of engineering kit that we get to look after. And it's all on a ginormous scale. It's all really, really big. And what that means is that it has some incredible energies there as well, because our job at Snowy Hydro is to manage water and make electricity, which is energy, but we've got to manage all of that energy. So my job is about making sure that we manage that energy nice and safely and keep it all under control so that we can make the electricity that turns on all of our electrical appliances at home.
Wow, thank you, Guy. That's a really important job. So everyone out there, K to 6, keep tuned, because you'll hear lots of different experiences here and some wonderful stories about STEM and careers. So our next person that we're eager to hear from is Sarah Rhoda, and she's a graduate mechanical engineer. Over to you, Sarah.
Thanks, Carolyn. Hi, everyone. I'm Sarah Rhoda, as Carolyn said. I'm a graduate mechanical engineer, which means I finished university 3 years ago and then started working here at Snowy in the graduate program, which is a very exciting program. Thank you.
Thank you, Sarah. That is an exciting program, and we'll hear more about that later on. Next, Craig. Hey there, Craig Leonard. You're an electrical engineer. Tell us what that's all about.
Excellent. Good morning. Thanks for the introduction, Carol. And yeah, as everybody knows, my name's Craig Leonard, and I've been with Snowy now for 4 years. I work down in Cairn Coban, tiny little town in the Snowy Mountains, and my role as an electrical engineer is to assist our maintenance team in looking after Murray 1 and Murray 2 power stations, all the electrical infrastructure associated with that. And yeah, on a daily basis, I'm supporting the maintenance team to keep those generators operational, to keep the lights on. Thanks, Carolyn.
Thank you, Craig. Well, that's extraordinary. Big assets to keep working. Thank you so much, Craig. Over to you, James. Now, James Perozzi works with water. He's our manager of water. Really? Tell us all about that, James.
Thanks, Carolyn. Good morning, everyone. So, yeah, my team, we've got a really great team of engineers and scientists, and we're all about understanding how much water we've got in the Snowy scheme. So we get out and we measure the snow in winter, how much water's sitting up there on the White Hills. We measure how much water is coming in each of the rivers and into our lakes, so that the business knows exactly how much water we've got at all times. And as Guy said, we generate hydroelectricity with that water, so it's really the fuel, it's really the lifeblood of our business. Very exciting place to work.
Thank you, James. Yes, indeed, it really is. So our next person is a graduate mechanical and mechatronics engineer, and I'm talking about Varden Robson. So we'd love to hear what that's all about, Varden.
Good morning, everyone. Yeah, as Carolyn mentioned, grad mech and mechatronics engineer. I'm kind of the newest kid on the block here. I've only been here for just over a year and a half. I work in a team currently with Craig over in Cairn Coban, and yeah, get to see some pretty awesome stuff and work on some pretty cool things. So tell you all about it.
Fantastic. Thank you, Varden. And now looking after our environment is very, very important to Snowy Hydro. And we're lucky enough to have on the panel today, Emily Martin, who is our Environmental Assurance Officer. Tell us what that's all about.
Hey everyone, yes, I'm Emily Martin and I'm an environmental engineer. So I've been working for Snowy for a little while and I'm now in a environmental assurance role. So that pretty much means that I'm on site all the time and I'm just making sure there's no environmental incidents and that the contractor is building our Snowy 2.0 project in accordance with all our approvals and design requirements.
Excellent. Thank you, Emily. So now that we've heard a little bit about our panellists and you've got to know them a little bit more, we're going to now launch into our questions. So to get our conversation going, today we're going to talk about Snowy Hydro and our renewable energy generation. So we're going to ask Guy and James these questions. So first of all, we're going to hear from James and he will answer questions about water of the Snowy Hydro, and then we'll throw to Guy and Guy will talk to us about the Snowy Mountain scheme and how it works. So over to you, James.
Okay, so I guess the story of the Snowy scheme starts really a long time ago. I might start with a little bit of a history lesson. So back in the 1800s, some really kind of pioneering farmers looking up at all the snow on the hills every winter and watching all this water flow down the Snowy River into the Southern Ocean. And I guess there's a lot of fertile soil out in the Murray-Darling Basin, but not always enough water to use that fertile soil for agriculture. And I know that Science Week this week is all about food by design, and the Murray-Darling Basin is really the food bowl of Australia, and Snowy scheme is an integral part of that story. So as I say, a lot of pioneering people looking up at the hills, looking at all this water and wondering how they could divert some of it westward out into the basin and use it for irrigation. Was always going to be a very challenging, expensive process to do that, and it wasn't until they realised you could build a hydroelectric scheme and harness the power of that water as it falls down the hills to create electricity with that water. And so in the 1940s, so still quite a while back, the plans really started to come together to have that mix of providing water for irrigation and energy into the growing population that was Australia's east coast at that time, and the concept of the Snowy scheme as it is today was kind of born. And I guess I'll get Guy shortly to talk about the construction side of things, but it was quite a long process, a really, really massive undertaking for the nation. From 1949 through to 1974, the scheme was built and comprises 16 large dams, tunnels, aqueducts, power stations, a huge amount of infrastructure that was all built through that period. With the whole idea to do both of those things, provide a reliable source of water for the Murray-Darling Basin for irrigated agriculture year in, year out, and also provide really fast energy to the national electricity market. So again, others will talk about this in a bit more detail than I will, but our electricity flows all the way up and down the east coast of Australia, all thanks to that water falling from the hills. So I might pass to you, Guy, talk a little bit more now about what was built and how.
Thanks, James. Yeah, so I guess the construction of the scheme, as James said, it started way back in 1949, but it was actually thought about much earlier than that. But it took a long time, a lot of engineers and everything working out how we were actually going to build it, because it was absolutely at the forefront of technology back in 1949, what we tackled. And our scheme today, as we know it, is still considered one of the engineering wonders of the world. It's an absolutely fascinating scheme, and it's made up of a number of dams, and the dams vary in size from quite small ones to it's up there with the largest dams in Australia. And they're all made out of different things. So some of our dam walls are complete concrete constructions, and other dam walls are what we call rock and earth fill dam walls. In the scheme, as we know it today, we've got 9 hydro power stations. And the other fascinating thing about that, every single one of the power stations is different. Every one is its own design. We've got a range of different turbine designs there as well. But really the scheme is just designed around collecting water through the mountains, getting it in those dams. And those dams form the energy supply that we use to drive the turbines, that drive the generators, that make the electricity, that go out through all of the power lines and power our homes and businesses right across the east coast of Australia. So all of us are very, very lucky and feel very privileged that we get to work on what is considered a national icon and some really cool bits of engineering gear. Thanks, Carolyn.
Oh, Guy, thank you very much. Thank you, James and Guy. Well, actually, Guy, that brings us to our next question. We've had a lot of our people very interested in just how snow melting can then be generated into electricity. I mean, Snowy Hydro is very unique, as we've just heard from James, that we use our snow water to generate power. But we've got some people out there in K-6 that are very, very interested in the mechanics of how that water goes through the turbine to actually generate that electricity. So, Guy, would you mind going first? And then I will, because you know a lot about T3, our biggest power station, and then I'm going to throw to Craig, who I'd love to talk about our Murray power stations. So let's start off with you, Guy, and learn about the mechanics of how we do what we do. Thanks, Guy.
Thanks, Carolyn. So the mechanics of a hydro power station. It's so fascinating because it's so simple in a way. So all we do is use the simple principle that water runs downhill, and we use that to make electricity. So how do we do that? We just talked about the fact that we've got our big dams right through the mountains in the Snowy Mountains. And all we do is we have a dam that's up higher than the power station, that's full of water. And then we build the power station below that dam, and then we have another dam below that power station. And then we build great big pipes that run from the dam down to the power station. We call those, the engineering term for those is called a penstock. So they're those great big white pipes you may have seen near our power stations. And they're made out of steel, really, really thick steel, because there's an enormous amount of pressure in those pipes. And all we do is we have our power station with our turbines, And we open a big tap, if you like, a big valve in the power station, and that allows the water to run from the dam up the top, down through that big pipe that falls through our turbine. Now, if you think of our turbines are just like a big boat propeller, if you like. So a big series of blades, the water goes in, hits those blades, makes it turn. So that's what makes our turbines spin. And that turbine then is connected via a big shaft to our generator. And the generator is what makes the electrical energy. And Craig knows a lot more about that, so he'll talk about that in a minute. But basically, one of the really important bits is that we can vary the amount of power that our turbines produce, and that varies the amount of electricity that our generators can make. So what we have is a governor system on our turbines, and the governor system is just like the accelerator in mum and dad's car. So the more you push the accelerator down, the more fuel that goes into the engine of the car, the more power it produces and the faster it will go. Our governor system is exactly the same. The more we open the governor, the more water that we push through the turbine, and that means the more power that the generator can make. So I'll hand over to Craig now, who will talk about how the generator actually makes electricity.
Awesome. Thanks, Guy. Yeah, so T3, where Guy's based, has probably some of our largest generators in the scheme. If I'm correct, it's 6 by 300 megawatt units. But over here in Murray, we've got 2 stations, Murray 1 and Murray 2 power station. At Murray 1, we've got 10 generating units and they 95 megawatts. So that's quite a lot of megawatts. So megawatts in terms of how can I relate it? A kettle probably about 2,000 watts or 2 kilowatts. So we've got a serious amount of kettles that we could run off one unit. So Murray 2 is below Murray 1 power station, and it's got 4 units, and they are about 130 megawatts. And Guy's done a really good job of illustrating on how the turbine works. Now, the turbine's actually mechanically connected to our generator. The generator sits above where the turbine is, and the generator spins around in something we call a stator. And it's basically 2 big magnets interacting with each other. And that rotational energy that we get out of our turbine gets put out on electrical conductors or wires. It goes through our big transformers and out onto those overhead power lines and into your house. And that's effectively how we generate power from that water that sits up on top of the hills.
Wow, thank you. Thank you, Guy, and thank you, Craig, for such a wonderful explanation. I hope that's helped those people out there that were wondering about that question. If you're not sure where these places are that Craig and Guy have talked about, you can go on to our website and have a look at the map. We have an overall map there, so that might help some of you kind of figure out where these locations are. So our next question is for James from the Water Management. Now, we've already heard from James about how Snowy Hydro was originally an irrigation project. And it's interesting to note that even though we actually here at Snowy Hydro do not own the water, we work with a range of organisations to meet water obligations. So I'm going to ask James now to talk a bit more about that. And the big burning question from you, K-6 out there, was how much water goes through the dams? How big is that? How much water goes through the dams and how quickly the water levels change? So James, we'd love to know more about that. Over to you. Thank you.
Yeah, fantastic question. So I guess that process that Guy and Craig just described, there's a term in the hydropower industry called water to wires. So between the snow falling on the hills, that water melting and the electricity coming out the other end of the scheme, there's all that fantastic stuff happening in our power stations and our dams. So every year, to meet all of our water obligations, the Snowy scheme is capturing and releasing somewhere over 2,000 gigalitres of water. So a gigalitre of water is really hard to picture, and 2,000 of them even more so. But there's enough water coming out of the Snowy scheme every year to fill Sydney Harbour over 4 times, just to try and put a little bit of perspective to it. Really, really large volumes of water, and most of that, as I mentioned earlier, is going out into the Murray-Darling Basin, into the Murray and Murrumbidgee rivers. It's captured by some other dams in those river systems, and then it's released for irrigation at the time when farmers need it, so predominantly over the summer period. But that 2,000 gigalitres that we're releasing every year, we can't release that water without generating electricity. We can't generate electricity without releasing water. So the two really kind of go, hand in hand, really, really neatly. But to release energy, or to generate electricity for the energy market, we have to be timing our releases to meet energy user needs all the time. So every 5 minutes we have a different target that we're trying to meet in terms of how much energy our power station releases, and our water release levels will vary as a result of that. So there are days where the Snowy scheme might not be releasing any water. There are days when we might be releasing, tens or hundreds of gigalitres. Again, a really tough number to picture, but if you talk about one of those large power stations like Tumut 3, there's enough water that we can push through that power station if we're generating a lot of electricity on a really hot summer's day to fill probably 2 Olympic swimming pools every couple of seconds. So everyone that's just watched the swimming at the Olympics in the last couple of weeks, imagine one of those. I think the actual numbers for that power station for T3, Guy, I believe, is every 2 seconds we'll be filling one of those swimming pools. So,
James.
but we can do that for hours and hours on end. So it's huge amounts of water, and that's just at one of our power stations, not looking at all 9 of them all together. So it takes a lot of water to create that electricity. But the great thing is that the water comes from the sky, and we'll hear a bit more about that whole water cycle a bit later on as well.
Wow, thank you. So for all you people that asked that question, those figures and numbers are enormous, aren't they? So by now, K to 6, you're probably realising that Snowy Hydro is a fairly complex business and quite unique in how we operate and what we do. Another amazing thing is that Snowy Hydro is in a national park, which is beautiful national and natural environment. So we've received quite a few questions from people that are wondering how on earth you can carry out operations with construction and doing what we do within the Kosciuszko National Park, and how we protect our environment when we're operating. Now, the perfect person on this panel to answer this question is Emily. Emily, I'd like to hand over to you. If you could talk us through a little bit more about how important the environment is to us and what we do surrounding that here at Snowy Hydro. Thank you.
Thanks, Carolyn. So the best message is that Snowy Hydro is a renewable energy company. So because of that, the environment is the focus of the company. We're committed to a renewable energy future, and so that's clean energy. So that will in turn mean our environment is protected. So the reason we can operate and construct in the national park is because we've got such a good track record. So we've been there for over 70 years, and we've done such a good job and have a really good relationship with the National Parks and Wildlife Service. So we work really closely with them every day, and we also engage with the community and listen to their concerns, and we really treat the park as if it's our own backyard. So protecting the environment really is integral to our business.
Thank you so much, Emily. And that's exactly correct. Very, very important part. And another aspect of our business that's number one for us is safety. So our number one for everybody here in our community and for our workers here at Snowy Hydro, it's a priority. Safety is our priority. And it's essential too if we're going to maintain our assets. Now, as you've heard, they're very complex and they're running all the time. So to maintain our assets and our power stations within the scheme is essential. So I'd like to cross over to Guy again. Guy, if you'd like to explain to our students some very important information about how do we actually look after our assets in the scheme and why do we do this? Thanks, Guy. And then, Guy, if you wouldn't mind handing over to Craig again. Thank you.
No worries. Thank you, Carolyn. And that is actually an incredibly good question, because it's a question based on us maintaining and inspecting our power stations and all the assets around them rather than fixing them. And the reason that that's important is for us, for our lights and everything to be on at home, and for us to use the tellies, we need the generators to be online. So we don't actually want the power stations and everything to break down. We want them to be going when we want them to be going. So that means we've got a very rigorous maintenance and inspection program that we've got in place. And that's all designed to make sure that our power stations don't break. We don't want to be fixing the power stations. We want to be maintaining them. So we do a whole series of things where we take the generating units offline and we go in and inspect things and we measure things and we check that things aren't wearing out. And if they're wearing out, we change them. So things like all of the belts that run the different motors and everything like that. And we check our turbines to make sure that they're in good condition. So our maintenance teams are out there always checking and inspecting things right through the power station, and we change everything out before it breaks. It's just like when you take your car into the mechanics and get it serviced. You don't take it in there because it broke down, you take it in there to make sure it doesn't break down. For our dams, they're really, really important to us. So we check those every day, and we go up and we have all of these different instruments and everything all over the dams and the power stations that give us all of this information to come back, and we check that things aren't changing and everything like that. So whole heap of different things that we do as far as maintaining the power stations, and that's also that when we want them to work, they work. So I'll hand over to Craig now, who will talk about some of the electrical stuff that we do.
Thanks, Guy. Yes, so Guy, as Guy said, maintenance is critical. We don't want anything breaking down, because if something breaks down, that interrupts our electricity supply to the national grid, and that's not what we want. So some of the bigger items that we maintain here in Murray include our transformers, our generators, even our auxiliary systems which support the generator itself, cooling water systems, lubrication systems. So we have a cyclical maintenance regime on our generators where we do a major inspection every 4 years. Get inside and inspect our bus bars and inspect stators and rotors. So the rotor is the spinny bit inside the generator, and the stator is the stationary bit on the outside. We make sure that all our protection systems are functional, which includes our circuit breakers, our overhead lines, any of our surge diverters. Basically, we look at our whole network just to make sure that it is reliable and they're capable of producing power and reliably putting it into the grid. We're actually quite lucky in Snowy because all of the equipment that we get to maintain was actually built very, very well back in the 1960s. And it was probably over-designed, but it's stood the test of time. And sometimes really, really good pieces of equipment to work on. So thanks, Carolyn.
Thank you, Guy and Craig. Well, we've received some other questions here again around our renewable energies. So with Snowy 2 being our biggest renewable energy project in Australia, people must have been thinking about that and reading a little bit about it for these questions to come forward. So we want to know a little bit more about how it's stored and how much energy Snowy 2, when it's completed, will actually produce. And there's another question. We've had some very big interest in our tunnel boring machines. We've got 3 names for those machines now, and I'm suspecting some of you have seen the information out there around that. So we have piqued curiosity there with our TBMs, as we call them. So the people that I'm going to ask from our panel to talk about this subject are Sarah and Varden. So firstly, let's go to Varden. Thank you.
Yeah, everyone. Yeah, so a little bit about, what renewable energy is. I think Sarah actually will be explaining that one. So I'll hand over to Sarah first, and then I'll go through some energy storage options that we currently have available to us at the moment.
Yeah, no problem, Varden. Yeah, so really great question, guys, is what is renewable energy? We talk about it a lot. You probably see it a lot in the news or in your curriculum, but what is renewable energy? So renewable energy simply is energy that is created or harvested from renewable sources. So that means that sources that aren't going to run out. So that's things such as solar from the sun. We're always going to have the sun, wind, and here at Snowy, it's hydro. So Snowy fits in nicely with the natural water cycle. So we've all probably heard of the water cycle before. So we have precipitation, so rain happens high up in the mountains, or for us here, it's so high up that it turns to snow. Then it settles on the mountains and then it melts, runs down our mountains, and we have our power stations there to capture that energy as it runs down the mountains. Then that water ends up in the lakes and it's released out to the sea, where it can then be evaporated and sent back up to the mountains. So that's how we fit into that renewable energy cycle of the water cycle. And there's various different ways that you can store it, which Varden's going to talk about.
Thanks, Sarah. So yeah, storage of energy comes in many forms. Most people are probably most familiar with chemical batteries. These are like your AA's and your AAA's that power your remotes and toys and whatnot. And energy storage is viewed by many as kind of the last piece of the puzzle in providing the world with 100% renewable energy, because everyone's aware that, the sun sets at night and the winds, it's not always windy. So you need to kind of store that energy when it is sunny and windy. And some of these forms of energy storage include like thermal storage, hydrogen storage, which is growing a lot lately, kinetic storage, which is a bit complicated, but I'll touch on it, and hydroelectric storage, which Guy will touch on at the end, because that's got a lot to do with Snowy too. Firstly, thermal storage. This basically involves heating a substance or an object that consumes energy. And you do that via electrical energy. So using this thermal energy stored in the substance, you can then create steam from water. That's the most common way that we then generate energy back into the grid using thermal storage. Recent Australian invention in this space of energy storage essentially uses, there's no other way to describe it, that's how they describe it, as a fancy cupcake which heats up, and then they use an analogy of chocolate chips, which is then stores the thermal energy in it. And then those chocolate chips, once you introduce water, that creates steam and drives a turbine. So that was a pretty interesting invention to come out of Newcastle University. And hydrogen is another storage which is gaining a lot of momentum. Basically involves splitting the water molecule, H2O, into just hydrogen and oxygen. So this is a process that consumes energy. And then when you're ready to, or when you need some more energy, you let the hydrogen and oxygen combine. And this is what supplies energy back to the grid. And this is gaining a lot of momentum lately, because the bonus of this type of storage is that it has the potential to replace petrol and diesel fuel in cars. They're actually already on the cars on the road with this technology, and great thing is the only thing that comes out of the exhaust is water. So that's pretty nice. And kinetic energy, this has been around for a while, but it's still pretty small time. It's basically where you just spin a large weight to very high speeds, and this is what consumes the energy. And energy is actually stored in the speed of the spinning mass. And then when you're ready to take energy out, when you need energy, you reduce the speed of that mass via connection to a generator, and then you supply electricity to the grid. And this takes me on to my last one, it's hydroelectric, and I'll pass over to Guy to talk about this technology and how it works with Snowy 2.
Thanks, Varden. So Snowy 2. What is Snowy 2? So I mentioned earlier that the scheme as we know it today is made up of 9 hydro power stations. So what Snowy 2 is that we're actually going to make 9 into 10. So we're building a whole new hydro power station. And Snowy 2 power station is going to be an underground station. So it's going to be built way, way down deep inside a mountain, and there'll be a great big tunnel that takes us down to get to that power station. So imagine driving down a great big tunnel and then all of a sudden you're inside a huge power station. So that's what Snowy 2 will be. And then from that power station in the mountain, we're going to build 2 great big tunnels that go to 2 of our existing dams, and that's where the water's going to flow. So how much energy will Snowy 2 produce? So Craig mentioned before about electricity generation and how many megawatts we produce. So Snowy 2 will produce 2,000 megawatts of power. And what that means is our power stations and everything are so big that we have to come up with sort of abbreviated numbers to put it into context, because a megawatt is actually 1 million watts of power. So Snowy 2 is going to produce 2,000 million watts of power. And that's basically enough to power well over 500,000 homes. So that power station would power all of Canberra City, if you like. And Carolyn also mentioned about our tunnel boring machines. So the big tunnels I talked about that are going to go from that power station out to those 2 existing dams, and the tunnel that's going to be allow us to drive down to the power station is going to be built by these tunnel boring machines. And they are really, really fascinating bits of kit. So they're this great big long, like hundreds of meters long round machine. And on the front of it is a great big spinning cutter head. And that big spinning cutter head chews into the mountain and creates a big round tunnel. And as it chews its way through the mountain, it drags the big machine along behind it, and then it lines the tunnel with concrete. So this big machine just chews its way through the mountain and puts this concrete lining as it goes. So we end up with just this great big, long, fully lined concrete tunnel. And our tunnel boring machines for this project are actually 11 meters in diameter. So across the front of them is 11 meters. So we'll end up with a big round tunnel that is 11 meters across, and that is huge. So that's how the tunnel boring machines work. Thanks, Carolyn.
Oh, thank you so much. That's fantastic. I'm sure that, excuse me, has helped our people out there listening in K to 6. And just while I'm on that, gosh, everyone, you've been wonderful. We're just seeing so many questions coming into us live right now, and we'll answer as many as we can. But I just want to acknowledge how wonderful your enthusiasm is, K to 6, and the most fantastic questions that we're seeing here today. So I've also received some questions from people wondering about if their hobbies that they do at home could actually help them for their careers in STEM later in life. So one of our people has actually asked, and very much, interested in, does playing Minecraft actually help you to enter into a career in STEM? So I actually know that a couple of our panelists have some very interesting hobbies that, help them in their day-to-day work here at Snowy Hydro. I'm going to ask Craig and Varden to tell us a bit about what they do and how some of these hobbies may have helped them further their career in STEM. So Craig, I think we'll go to you first.
Thanks, Carolyn. To be honest, I do use some technology, wonderful Google, to actually figure out what is Minecraft. Back in the day, I used to play pinball and Tetris, so probably giving me age away. But the Minecraft game itself was, it's a resource-based, virtual reality game, and it's definitely something that can challenge your brain. I think there's strategy in it, and definitely has some sort of technology application. My hobbies as an electrical engineer tend towards electronics at home. I tinker around with Arduinos and Raspberry Pis, and even the kids have got technology. They got a Sphero, which is a robot essentially, and even though programming. So plenty of stuff to do while we lock down. But yeah, it definitely, it's all those hobbies that have driven my thirst to become an engineer and to ask more questions. But yeah, maybe Varden can elaborate on his hobbies and why he took the mechatronics path. Over to you, Varden.
Thanks, Craig. Yeah, like Craig, I am not too familiar with Minecraft. It's a little bit before my time, but I do understand that, you basically use the resources you have around things to create things, tools, and solve problems. So that aspect of it's definitely relatable, but I'm not sure how technically correct it is, and I don't think you get very far with a golden axe here at Snowy Hydro. But anyway, growing up, what I did, I was pretty bad at, is I did break a lot of toys, much to my parents' frustration, but it was mainly out of curiosity to see how they actually worked. But unlike now, I didn't have to worry about putting them back together. Back then, I just got in trouble. And as well as this, I also grew up sailing, which involves a lot of tinkering and maintenance of the equipment that you use to make sure that your boat is as fast as possible so you can try and beat your competitors. And naturally, this kind of evolved into an interest in STEM. I didn't realize it at the time, but you do a lot of problem solving and using resources and tools that you have on hand to solve problems. And the thing with STEM is it basically a study of how the world around you works. So that kind of played into that a bit. And mechatronics really played into this interest of tinkering that I developed in sailing. And at university, this was mainly came across when I was involved in building a small robot. That was a little individual project that we did in mechatronics. I really enjoyed that. And my final year project was I was part of a team to build a University of Newcastle's first electric race car. So, that I put a lot of hours into that race car, but if you're doing something you really enjoy, it wasn't really a chore. Like that last year kind of flew past me and I had a lot of good memories, and yeah, I really enjoyed it. So the hobbies that you develop when you're younger definitely can help you throughout your career.
Wow, thank you very much for those two reflections on what you did, and thank you for that question. So I'm really glad that someone's asked us here about how many scientists we have at Snowy Hydro, because we have people from very diverse backgrounds, from geology to weather. So to hear a little bit more about what scientists we have, I'd like to ask James to answer this question. Over to you, James.
So one of the really exciting things about working at Snowy Hydro is all of the different equipment that we have to work on and all of the different systems that make the business work. So to make our business work, it takes a whole lot of really, really smart people, and we're really lucky to work with people in all fields of STEM. So a lot of us on the call today are engineers, and that's really a form of applied science. But we have people that are experts in, as I say, every part of STEM. So yeah, Caroline mentioned geology. We have atmospheric scientists who are meteorologists that help us predict the weather. We have scientists that are experts in maths and economics and things to help us understand how the business works with all the other businesses in the energy market. In my area particularly, I guess in the water space, as I say, we have scientists that help us understand what weather we've got coming, today, tomorrow, this week, all the way out into next year, what we expect. Is it going to be a wet year or dry year, and how much water are we going to have to use? With those forecasts, we then have another group that help us to understand exactly how much inflow we're going to have and where it will be, so that we can make sure we've got the dams at really good levels to capture that water and harness it. Yeah, the possibilities are really endless, I think, when you talk about a career in STEM. And not just for Snowy Hydro. I think most businesses, there's a lot of really, really clever people with a bit of a curious mind in the background making the place work.
Wow, so many different opportunities here. Thank you, James. Well, do you know what, K to 6, not only with all the different scientists we have here, we also have a huge range of engineers. And I actually didn't know how many engineers and various areas of engineering there were until I started here at Snowy Hydro. So I'd like to ask Varden to kick off this one. And then Varden, would you mind passing to Craig? And then we'll have Sarah and Emily. All right, let's go. Thanks, Varden. Tell us all about engineering.
All right, well, I'll just cover off kind of the areas of engineering that I studied at university. I'm a mechanics and mechatronics engineer, and basically that happened because I couldn't decide what I wanted to do. So I initially started off in mechatronics, and while I was at university, I actually changed 3 times before deciding that I couldn't make up my mind, so I did both. And what that allows you to do, especially here at a place like Snowy Hydro, where you've got such a mixed bag of engineers, like Carolyn mentioned, is that I can kind of flip-flop between disciplines. So far I've worked on electrical and mechanical teams, and I've also done some mechatronics things. So yeah, that's been really good here at Snowy Hydro, and there's not too many places out there where you do get those opportunities. And I'll pass over to Craig.
Oh, thanks, Varden. So my current role is electrical engineer, but I kind of started out at uni back in 1997, so probably giving me age away a bit. And I've accumulated some really, really interesting career experience over the course of my life. When I finished university, I did a single degree, electrical power engineering, because I knew that everybody's going to need power. I started out in a petrochemical industry where I worked really closely with control systems engineers and chemical engineers. I then made the move over to Australia and got involved in mining. And in mining, we get involved with conveyor systems and crushers and flocculation plants and a range of industries, smelters. After that, I moved over to Newcastle, where Varden studied, and I joined Hunter Water Corporation. Now, why would you say, well, would an electrical engineer be involved in the water industry? And I got involved with water and wastewater engineering. During that time, also did a bit of automation design for Port Waratah Coal and NCIG, and then moved into a research and development role. So just having a single title doesn't limit you to a certain type of job. And the R&D role that we were doing carbon abatement technology for the CSIRO. And then after that project finished, adverts came up and they were looking for an electrical engineer at Snowy. So now I work down at Snowy Hydro, which is quite ironic because I studied the scheme when I was originally studying in South Africa. So you never really know where you're going to end up in life, and the electrical engineering or science technology arena can take you anywhere. So yeah, that's just a brief history of where I'm at, and I might stick around with Snowy for a while longer yet. But yeah, over to you, Sarah.
Thanks, Craig. So I went to university and studied mechanical and sustainable energy engineering, which is a named degree that my university offered. Essentially just means that I really got to focus on renewable energy, looking at solar and wind and designing those sorts of systems, which was really what I was passionate about. So I was really lucky to do that. And then I was from South Australia, so there wasn't too much going on around there. We've got some wind and some solar, but what really interested me was hydro. So I moved across here over to Coomera in New South Wales to work at Snowy Hydro, and have absolutely loved it so far. So yeah, that's a bit of my career journey. Over to you, Em.
Thanks, Sarah. Yeah, so I studied environmental engineering at uni. And for those that don't know, that's pretty much like civil engineering, but you're more looking at the impact of civil infrastructure on the environment. So I did a range of subjects. I did soil mechanics, water engineering, transport engineering, and then also some sustainability and environmental approval subjects. So it was a very diverse degree, and I felt like There's many different directions you can take with that degree. But at the moment, I'm in the environmental space, which I'm really enjoying. I've always had an interest in the land because I grew up on a farm. So I always thought I would end up in a job that helps to minimise harm to the environment and protect the land. Thanks.
Thank you. Oh, some fantastic stories. It just makes me want to keep on going, but I know that I can't. But that doesn't mean we can't do this all again. So stay tuned. So I've had some questions about people that are really thinking well into the future, K to 6, and that's about what opportunities are here at Snowy beyond year 12. So I think I'd like to hand that over to Vardhan and Sarah. Vardhan, would you like to go first and talk to us about your vacation student experience? And you know what, K to 6, that means Vardhan spent his holidays working here at Snowy Hydro, but we'll hear more about that. And Zara, who will talk about our Snowy graduate program. All right, over to you, Vardhan, first.
Yeah, g'day. I'll say it sounds a lot worse when Carolyn puts it like that. It wasn't really that much work. It was, there was a lot of work, but it was good fun. Like, as I said before, you know, if you're doing something that you enjoy, it doesn't really seem like work. And the vacation program at Snowy, I did that 4 years into uni. So at the end of my 4th year, you have a summer holiday for 3 months at uni, and I spent those 3 months down here at Snowy, and it was a great opportunity to practice what you learned at university and apply it to some real world problems. That's a bit of a link that's missing sometimes at university. So that was really great. And it was also a really eye-opening experience about the world of power generation and how much work goes on behind the scenes to keep the lights on around the country. That was, before I came down here, I thought I knew a little bit about it, but when I started working, I realized I knew nothing. So that was a really eye-opening experience, and I really enjoyed that. And also I got to experience the great lifestyle down here in the Snowy Mountains, which really is also a great way to spend university holidays. So over to Sarah.
Yeah, thanks, Vardhan. You loved it so much that you came back as a grad, which is exactly the same thing that I did. Did my vacation program between my 3rd and 4th year of uni and came back when I finished my 4th year of uni. So yeah, Snowy Hydro offer a graduate program, which is a really awesome program. It's a 3-year program where you switch out into different engineering roles or whatever stream you're going through. You move around every 6 months into different teams and get to trial out different areas of the business, which is a really great way to start your career and sort of work out what you want to do, because Snowy has such a diverse range of teams and jobs, as you would have seen from all these panelists. We're all from different teams here. So yeah, it's a graduate program is a great way to be able to test out the waters and find where you fit at Snowy.
Thank you. Thank you very much, team. So K to 6, you're probably getting the idea that we've got a range of experts across so many parts of the business here with different skill sets. So I think we're getting the picture here with these stories that sometimes education's not a clear straight line and your career can take all different turns. So to hear a little bit more about our other panelists and their career stories, I would like to hear from James and Emily and Guy, because we haven't heard what twists and turns and how you started with your careers yet. So let's start with James, please.
I'll keep it pretty short and sharp. I grew up in Sydney, and like some of the other guys, was always very curious about how things worked. And after I finished school, I actually started studying industrial design, which is all about designing, you know, things like mobile phones and toasters and making sure things look really good. But after a little while, I found that I was actually more interested in how they actually work, and that's when I turned to engineering and civil engineering. And I guess Snowy Hydro has an example of just about every single civil engineering construction that you can think of, from dams to tunnels to power stations, roads, bridges, buildings. It's a fascinating place. So I moved down here to the Snowy Mountains about 12 or 13 years ago now, and have worked on most of those types of constructions, and also now quite differently working on just how we manage the water. So yeah, lots of different opportunities out there and different ways to end up in a field that is interesting.
Guy, would you like to go next?
Yeah, thanks, Carolyn. As soon as I find the unmute button. Excuse me. So my career actually started as a trade-based career. So I did an apprenticeship. I did an apprenticeship in metal fabrication and welding. So basically that meant I got to build big things out of steel. And as a kid, I was just fascinated by machines and big machines and how they all work. So I did a trade where I got to build those things. Then I did a second trade where in fitting and machining. So I learned how to pull big things apart and fix them and put them back together. And I absolutely love my trade. And then I moved into management and leadership roles. So I went from being part of the team that built the stuff and fixed the stuff to managing and leading the teams that build the stuff and fix the stuff. And I always worked in heavy engineering, and the bigger the stuff, the better, as far as I was concerned. And I was very lucky. I used to come on holidays down to the Snowy Mountains, and I seen the hydro power stations, and they are seriously big and they are seriously cool. And I always thought I would love to have a go at working on those. And I was lucky enough to get a job with Snowy Hydro, and I got to look after what is my favourite power station. I know you shouldn't have favourites, but my favourite is Tumut 3 power station. It's the biggest one in the scheme, and it was a really cool job to be responsible for that particular power station, because like the units there, each unit, for example, we talk about big stuff, the turbines, 400,000 brake horsepower. Each one of them, the bit that spins, weighs over 700 tonne, and they each produce over 300 megawatts. So it's engineering on a grand scale, and it's really cool to get out of bed every day and go and be responsible to look after something like that. So and all that comes from the fact that I was interested in STEM, and STEM has, really shaped my career.
Oh, everyone, I've just realised we've been chatting for so long, we're nearly out of time. So Emily, could you answer your part of this question into our last big burning question for all of you? I just wanted to reflect on everything that you've been saying today, everyone, and we've heard some fabulous stories. So to tell all the children out there today from Canberra, Sydney and across New South Wales, what advice would you provide to these students about pursuing a career in STEM? Go.
Yeah, so STEM, it's very, very difficult and challenging, but if you love it, then it's worth it. You've just got to stick with it, and you won't regret it, and you'll have a great career.
Sarah.
Yeah, absolutely. If you have a passion for, maths or physics or science, anything that's related to STEM, have a go. Just try it out. Not everyone, finds exactly what they like straight away. So just try it out and see where you end up.
Varden.
Yeah, I'd say if you don't have the grades, don't stress too much about it. As long as you got an interest and a passion, I'd go for it. STEM careers are only going to become more and more important as the world around us evolves, and we get more and more technology and science around us. So, yeah.
Craig.
Yeah, I'd have to agree with Varden. Pursue your passion. STEM is all around us. Get online, grab an Arduino or a Raspberry Pi, go through YouTube, become an expert, see what fits with you, and just keep an open mind and continue learning. You'll figure out what fits with you. So, yeah, go for it.
Thank you. Guy?
My advice would be to really take the time to have a look at all of the different careers out there that relate to STEM. as everybody said, STEM is all around us. It's what's formed all the technology that we get to play with and makes our lives what it is. So really take the time to have a look at all of the careers out there that are available to you.
James, final word.
I think all I'd like to say on top of what everyone else has just said is stay curious. There's a lot to learn out there and enjoy it.
Fantastic. Thank you, panels. I have to acknowledge that we've had over 200 live questions submitted to us today. So it seems to me that this is the beginning of something big. So I can see a virtual panel coming online again in the near future. I want to thank all of the schools and all of the parents and all of the teachers that are trying to get through and navigate their home learning. I hope we've helped you a little bit with that today. You've heard here today some fabulous stories about perseverance, about passion, about following your heart and trying and keep trying. So I'm excited that we've been able to present this to you today. And I just want to do a quick thank you to all the people behind the scenes that have made this happen for us to be able to bring this live virtual experience to you all. I've enjoyed being the host here today. I hope you've all enjoyed it. We look forward to our next panel. And from Snowy Hydro, happy National Science Week and goodbye from our virtual panel Q&A session. Thanks everyone. Bye.